Hello everyone. Today's question, how to decide aromatic, anti-aromatic and non-aromatic. So we will see first the necessary conditions that must be fulfilled when we will choose these three. So the basic difference and also the necessary conditions that we are going to see. When it is aromatic, the conditions that are required, it must be cyclic, conjugated all the way around the ring. That means conjugation must be present all over the ring. And if you have any confusion related to conjugation, you can watch the video that I have made that is related to conjugation, and for that you can click on the link appearing on the screen. Now the fourth condition is 4n plus 2 pi electrons must be present. Here n is basically 0, 1, 2, 3, 4. So when you put n equal to 0, it will be 2. Then the next value 1, then it will be 6. Then for 2, that is n value 2, it will be 10. So in this way, the series will continue. That is the third condition, and obviously it should be flat or planar. And aromatic molecules are very stable. When it is anti-aromatic, now only one factor is different, and that is this factor. You will see the other three factors are actually same. Okay, so all the three conditions same, but now 4n pi, that means n value 0, so it is not possible actually. Then when n is 1, it is 4. Then n is 2, it is 8. N is 3, it is 12. So the series will continue in this way, 4, 8, 12. In the previous case, you have seen it is 2, 6, 10 like this. So now for anti-aromatic, it is very unstable. So as if these two are the extreme. One is very stable, another one is highly unstable. What about non-aromatic? Now in case of non-aromatic, when any of these conditions that I have mentioned in the left hand side not fulfilled, any one, okay. And what about the stability? What it is written here, it is anything in between. That means it is not very stable like aromatic, it is not very unstable like anti-aromatic, it is something in between, okay. So now one by one we will see with examples. When it is aromatic, these conditions must be fulfilled, that we have seen already. Now here we have these three molecules, all of them are aromatic. Now benzene is very common, so I'm not going to that. So for pyridine, if we try to see how the conjugation is going on, because it is cyclic, that is clear, it is planar. And what about the conjugation? The conjugation will be like this. So the next picture, it will be, now the double bonds, they have exchanged their positions, right? But see, the lone pair over nitrogen, that is not part of conjugation. It is intact. But conjugation is present, and obviously here 6 pi electrons are there, total 3 pi bonds you can see. So all the conditions are fulfilled. Cyclic, conjugation, 6 pi electron, and it is planar. And what about the next one? The next one is, there are 2 pi bonds, but there is a negative charge. Now this negative charge is now, unlike the previous case, now it is part of conjugation. So I can draw the picture now. The double bonds are here, negative charge is here, okay. So this is also cyclic, conjugated, 6 pi electron. Now how it is 6 pi electron? Because the negative charge is also taking part in conjugation, so you have to consider this as 2 electrons. So total 6 electrons again, just like previous case. So in all these three examples, there are 6 pi electrons present, and the other factors, that is cyclic, conjugation and planar, all these three factors are also fulfilled, okay. Now what about the next one, that is non-aromatic. Okay, before going to that, I would like to mention that sometimes we have some confusion regarding these pi electrons, that is how many pi electrons are there. Suppose if there is no heteroatom, it is only hydrocarbon like naphthalene or benzene, it is easy to decide. But when there are some heteroatoms with lone pairs, or if there is some negative charge, how to decide that? So here we have all these examples. The first one, that is pyridine, we have already seen it. Here this nitrogen is basically sp2 hybridized. So this p orbital, which is part of this conjugation, this is basically unhybridized p orbital. And these two sigma bonds, sp2 orbital is inward, another sp2 is containing this lone pair. But remember, this lone pair is not taking part in conjugation, and it is perpendicular. If you consider these p orbitals that are taking part in conjugation, this lone pair, it is perpendicular to this. Fine. So it is not part of conjugation. Now what about the next one? The next one is basically phenyl carb anion. Simple benzene ring, but there is a negative charge. Here also same thing. This lone pair, it is not part of conjugation. Conjugation is present only in these 6p orbitals. Okay. Now what about the next one? It is furan. Now in case of furan, there are two lone pair present over oxygen. One of these lone pair will take part in conjugation, then only it will become 6 pi electron. So see, among these two lone pairs, only one lone pair is taking part in conjugation, and this oxygen is basically here sp2 hybridized. So 1p which is not part of hybridization, that will take part in conjugation, and another sp2 orbital is containing this lone pair, but it has nothing to do with conjugation. So just consider one, and now it will become 6 pi electron. So basically here all the pictures that you are seeing, it is 6 pi electron, and all of them are actually aromatic. But how 6 pi electrons we are getting, that is the point of discussion. The next one is pyrrole. Here nitrogen has only one lone pair, and this lone pair is also taking part in conjugation, then only it will become 6 pi electron. Okay, and the next one is imidazole. Now you have two nitrogen. There may be some confusion. See, number 1 nitrogen, it is not part of double bond, but number 2 nitrogen is part of double bond. Now among these two nitrogen, only nitrogen number 1, which is not part of double bond, see, which is not part of pi bond, that can only donate lone pair, and it will become part of conjugation. But this lone pair, it is intact. Now if you consider these two, there are total 2, 2, 2, again 6 pi electron. So in this that is slide, all the 5 molecules that are seen, all are basically aromatic, and all of them are 6 pi electron. They are cyclic, they are planar, and conjugation is obviously present. Fine. So in this way you can decide how many pi electrons. Now the anti-aromatic, we know only this third factor, this point is different if you compare with aromaticity. Unlike otherwise there is no such difference. And this is important. This is very, very unstable, because sometimes questions are framed in this way. Suppose 3 to 4 examples are given, which one is very unstable, then you can choose whether it is anti-aromatic or not, because if it is anti-aromatic, obviously it has to be very unstable. So here we have these 3 examples. Now here you can understand easily, it is 4 pi electron, so it is cyclic conjugated 4n pi electron, and it is planar. Now the next one, here these two lone pair you have to consider. So as if it is taking part in resonance, and now nitrogen is positively charged, there is negative charge here. Fine. So this is also 4 pi, and the next one, here conjugation is possible, because conjugation must be there, that is the necessary criteria. Newly generated positive charge. So in this way you can also draw the other resonance structures, but important point is here also it is 4 pi electron. Fine. And the last one, non-aromatic. So when any of the 4 conditions will fail, then you will choose it as if it is non-aromatic. Now if you look at this picture, it is just like naphthalene, only these 2 carbons, they are not connected to each other. So there is hydrogen. Now these 2 hydrogen, if you consider this type of planar structure, these 2 hydrogen, there will be some steric hindrance, that is steric interaction between them. So to avoid that, this molecule ultimately becomes non-planar. So that is why the picture, it should be like this. This is not the correct way to represent this molecule. So in this case, the first 3 points are fulfilled, but this point is not fulfilled, it is not planar. So we cannot say it is aromatic. Okay, last point is not fulfilled, so that is why we should treat it as non-aromatic. But one interesting point, if you connect these 2 carbon by a CH2 group, this is CH2, now the molecule becomes planar. So as it is planar, conjugation is possible, because in the previous case, because of this non-planarity, conjugation is disturbed, but in this case it is possible, and hence it becomes aromatic. Another example of non-aromatic. So this molecule you can represent in any of this way, right? But no, this is not the correct way to represent, because when you are representing it in this way, as if it is planar, all these points are actually fulfilled, right? Cyclic conjugation 4 and pi, because it is 8 pi electron. So it seems as if it is anti-aromatic, but remember, anti-aromatic is very, very unstable. So to escape that fact, to escape this anti-aromaticity, or you can say, better way to say, to escape this unstable condition, it will convert to this type of tub shape. So now it is no longer planar. So only the first three conditions are fulfilled, this one not fulfilled. So that is the reason, again it is non-aromatic. Okay, so in this way you can decide. Just you have to check whether these factors are, these four factors as mentioned, it is present or not. So I hope now you have some clarity, and you can easily choose which one is aromatic, non-aromatic or anti-aromatic. Okay, thank you for your precious time.